This is Module 16, Lecture Notes 32. Today we're going to continue talking about redox reactions. Remember that stands for oxidation and reduction. Today we're going to talk about oxidation and reduction reactions as a whole. Last time we learned how to assign individual oxidation numbers to atoms within an element, but today we're going to apply that to actual reactions. The first thing we want to do is understand the difference between these two words. Oxidation is when an atom loses electrons. So remember that electrons are negative. And when you lose something negative, you become more positive. So when something is oxidized, you will see that it becomes more positive. And then the opposite is true. For reduction, an atom will actually be gaining electrons. Well, if you gain negative things, you will become negative. That's how I always remember it. Okay, I do have a couple little sayings to help you remember the difference between oxidation and reduction. This is Leo, our lion. He says, grr. Leo says grr. Loss electrons is oxidation. Gain electrons is reduction. Leo, grr. The other one that you will commonly see is the word oil rig. Oxidation is loss, reduction is gain. So just have those two little sayings kind of in your brain that you can write on the side of your homework paper or on a quiz, and that will help you remember the difference between oxidation and reduction. Now that we know the difference between those two terms, let's look at what happens to an atom in a reaction, and we have to decide if it was oxidized or reduced. So it says sulfur goes from an oxidation number of -2 to +5. I always like to think, what is it doing? Is it becoming more positive or more negative? And in this case, it's becoming more positive. So that tells me that it was oxidized. Then the question says, how many electrons participated in this change? So by how many more positive did this become? And if it helps you to draw a number line, you can do that. Okay, we started down here at -2 and we ended up at +5. I think most of you can see that that would be 7 electrons that were gained in order for this to be oxidized. So the overall is a change of 7 electrons. Our next example says that an atom goes from +5 to +2. So if you're thinking about it in these terms, is it becoming more positive or more negative? +5 to +2 is actually more negative. So in this case, our atom was reduced. How many electrons participated in this change? 3. I'd like you to look at this last one, decide what you think for these two answers, and then we will check it together. An atom goes from -7 to -1, it's becoming more positive, which is oxidized, and it's a change of 6 electrons. On the back here, let's look at some redox reactions. So we call something a redox reaction when an atom's oxidation number changes. So if any atoms change their oxidation numbers in a reaction, we call it a redox reaction. When one element is oxidized, another element is reduced. These always happen simultaneously. If something is gaining electrons, well, something else must be losing them. They have to happen at the same time. And that's what I've written here. Okay, so that is the definition of a redox reaction. Okay, in these examples below, we're going to determine if it's a redox reaction or not. And if it is, we're going to decide which elements were oxidized and which were reduced. Over here to the side, I want you to write down 2 steps for doing these. The first thing you need to do is assign oxidation numbers. Because that is the only way you will be able to tell if something changes. We need to go through and assign those oxidation numbers to everything. Then you're going to decide if there's a change in the oxidation numbers. And you're going to do that for each element in the reaction. You may want to pull out your rules from last time and have those handy, and also have your periodic table. The rules I'm referring to are the ones that are at the bottom of your lecture notes 31. So for this first example, we have calcium reacting with chlorine, making calcium chloride. So above each of these, I need to assign an oxidation number. Remember, if it's by itself and it's neutral, it has an oxidation number of 0. What about for calcium chloride? Remember that group 2 metals, like calcium, will always be a +2. So that makes each chlorine a -1. All right, so I've gone through and I've assigned my oxidation numbers. Now I need to decide if anything is changing, and if it is, what is changing? So let's look at calcium first. It starts with an oxidation number of 0, and it changes to a +2. Chlorine starts as a 0, and it changes to a -1. This is a redox reaction, where your elements are taking on different oxidation numbers in different parts of the reaction. So down here below, I want you to list your 2 elements. And you need to tell me which one is oxidized and which one is reduced. Calcium starts as a 0 and it goes to a +2. So it's getting more positive. It's losing electrons. That is oxidation. Chlorine starts as a 0. It goes to a -1. It is gaining electrons. It's getting more negative. This is reduction. Okay, and you can even write in parentheses what's happening so that you remember. It starts as a 0 and it goes to +2. Chlorine starts as a 0 and it goes to -1. Okay, we are going to skip this reaction. It's just not the best example that I want you to have in your notes. And we will work through one more together. I want you guys to go ahead and assign oxidation numbers to every element. We'll come back and check those, and then we'll decide if it's redox or not. For this one, I started with fluorine because fluorine's always a -1, and there's 5 of them. So iodine needs to be a +5 in order to balance out and make neutral. Iron by itself is a 0. Here I have +3, -1. plus 3 minus 1. These coefficients out in front are just used for balancing. They do not have any effect on the oxidation numbers. So I'm going to write coefficients don't matter here. You don't need to use those for what we're doing, and they have no effect on the oxidation numbers. All right, the next thing we need to do is to look at each element individually and decide if it's changing its oxidation number throughout the reaction. So we have iodine, we have some fluorine, and we have iron. Remember, iron is Fe. So let's look at each of these individually. On this side of the reaction, iodine starts as a +5. And if I find it over here, it goes down to a +3. So I start at +5 and I go to a +3. It's getting more negative, which means it's gaining electrons. It is reduced. Okay, let's find fluorine and follow it. Fluorine starts as a -1, -1 here. It's also -1 there. Fluorine does not change throughout the reaction. And then iron, Fe, starts as a 0 and it ends up as a +3. It's becoming more positive, which means it's losing electrons, and this is oxidation. Okay, so we have reduction and oxidation happening in the same reaction. This is also a redox reaction. Okay, so I think you guys see it's really important to assign your oxidation numbers and make sure they're correct, and then just carefully follow each element through the reaction and decide if it's being oxidized or reduced. Lastly, I just wanted to say thank you guys so much for being flexible this year and for being willing to try a new format for this homeschool class. I just appreciate you being willing to have an open mind and to try this with doing notes at home and the rest in class. I hope you've learned chemistry and you've had a great experience. The other thing I always tell my students at the end of a class is to save, at the very least, your notes. Okay, you probably don't need to save your homeworks, your quizzes, your labs. If you want to, you can. But those students who think they may be going on to college and will probably have an introductory chemistry course at some point, I really encourage you to put your notes in order. So save your notes pages, put them in order, stick them in a folder. You never know when you're going to want to pull these out, and just have a refresher on some of the basic chemistry principles that you learned in this class. So I hope you do that. I hope it helps you in the future, and thank you guys for a great semester.